Okay, so for the triangle,
For a triangle, it's 600
minus
negative 200x plus 600
multiplied by
x
divided by
2.
Correct. Yeah. So for the triangle is supposed to be 600 minus 200 plus 600. Okay. Multiply by x divided by 2. Okay, I think I will just concentrate on the concentrated force first. So for the rectangle just now, it's supposed to be rectangle. It's supposed to be minus 200 plus 600 multiplied by x. And triangle, it's supposed to be 600 minus 200 plus 600. Okay, this you multiply it with x per 2, like this, right? So the summation of both will be the concentrated force, right? Reinhard? Hey, Reinhard, Timothy?
Yes.
Or you can do some other thing as well. Okay, you can just sum this and this divided by 2. Okay, divided by 2 multiplied by x. So like the average of both, right? The average of this and this multiplied by x. Okay, total it can be like 600 plus minus 200x plus 600 plus 600. This one you divide it by 2 and then multiply it by x. Okay, what I did here is to find out the average value between the left edge and the right edge because it's linear. Okay, 600 plus the minus 200x plus 600 divided by 2. Okay, that's the average of both and multiply it by x, and that's what you get for the total area. Okay, Timothy, do you get it, Timothy?
Yes, sir.
Both is supposed to giving you exactly the same results. Okay, both supposed to be giving you exactly the same results.
Sir, can I ask?
Yep. Alberto?
For the calculations of rectangle and triangle, why don't we use minus 200x? Why is it only minus 200?
I made a mistake here. It's supposed to be minus 200. Minus 200x. Yes, correct.
Oh, okay, thank you.
That one is supposed to be minus 200x. My mistake. Okay. So, but anyway, the summation of these two is supposed to be exactly the same as this one. You can try, but the results will be the same. Okay. So I think I will just use this one. In this case, what I have is 100x squared minus 100x squared, and then 600x. Okay, so this one is supposed to be minus 600x minus 100x squared. That's the total of this, right? 600 plus 600, 1200 divided by 2 is 600 multiplied by x, 600x, and minus 200x divided by 2 is minus 100x multiplied by x is 100x squared, like this. And the total is supposed to be equal to 0. Okay, so our phi here is supposed to be 450, okay, minus 600x plus 100x squared. Okay, so this is our equation for free. Yep. Any question here?
Wait, sir, can I ask?
Mhm.
How did you, can you repeat where you get 600x minus 100x squared?
This one. Alberto, just now I told you, right?
Oh, okay,
The
okay, okay.
total
Oh,
is
yeah, I get it, I get it. Okay, okay. Sorry, sir, I get it.
the average between the left edge and the right edge multiplied by x, right? That's what I did here. This is the average, and this one is x. Okay, and then after I calculate this is the results, right? Okay, then I think that's all for the phi, and now let's calculate for the m. Okay, for the moment, what should we do there? Okay, this one, the calculation is very long, yes, but it can be done. Okay, for the moment, in terms of moment, I think it's better for you to just use rectangle and triangle, because for the rectangle, we know the center of the location is in the middle, like this, x per 2, and the triangle, the location is 1/3 from the left edge here. Okay, so we have for the rectangle and triangle there for the moment. Okay, the rectangle, this one is the value, the triangle, this one is the value. Okay, now for the moment, just now Timothy, still Timothy, can you help me to find the equation, Timothy?
Yes.
I think in order to make it simpler, right? It's better for us to just use, because I don't want to put phi there. So just use this one, sigma moment at that particular point, at the right edge. What we have there?
We have m.
Okay, m. So counterclockwise is positive. What else?
Ay.
M, then ay. Ay multiplied by what?
Ay multiplied by x.
X. Negative or positive? Don't forget about it.
It's negative.
Negative. 450 multiplied by x. What else?
Then we have rectangle multiplied by 2/3x.
Rectangle.
Oh, I mean triangle.
Triangle multiplied by 2/3x, correct?
Yes.
So triangle. And for the triangle, is positive or negative? Positive, right?
Positive.
Positive. Triangle is 600 minus 600 is 0. Oh, so the triangle is 600 minus 600 is 0. And positive 200x. Okay, so triangle is only positive 200x, right? This one, positive 200x multiplied by x per 2. So positive x 100x squared. So plus 100x squared multiplied by 2/3x, like this, right?
Yes.
Okay, and then about the rectangle.
Rectangle times x/2.
Rectangle times x/2. So what we have here is minus 200x, this one is plus, minus 200x squared plus 600x multiplied by x per 2 equal to 0. Like this, right? Okay, so later the moment will be, you have to join the terms, 450x minus 66.66 x to the power of 3. Okay, and then minus 100x to the power of 3, and then plus, sorry, this one is supposed to be minus 300x squared. The plus and minus, I think I made a mistake here. For x, okay, minus, okay, this one is become minus, so that one is become plus, this one is become minus. So this is the equation. We can simplify it again. So the moment will be 33.33 x to the power of 3 minus 300x squared, okay, plus 450x. Like that, right? Timothy, correct, right? Timothy?
Yes.
And for the phi, this is the equation. Okay, and maybe for some of you are wondering, how can we draw the distributed force and distributed moment and at this particular span? Because this equation, okay, only works for x between 0 to 2 meters. The same for this one. Is for x from 0 to 2 meters. Okay. Later, for the x between 2 meters to 3 meters, we have to develop another equation. Okay, we have to develop another equation. Okay, but this one is the one for this, and for phi and moment for x between 0 and 2 meters. That's the equation. Okay, I think I will try to finish it then. If we want to cut here for the second cut, because it will be simpler to cut it from the right side. Okay, to cut it from the right side. So the second cut, it will be like this. Okay. This one, it will be not, it won't be x anymore, but what we call it right now, Timothy? Instead of x, it's supposed to be what? If I use this one.
3 minus x.
Right. It's supposed to be 3 minus x. 3 minus x. Okay. And the internal force, this one for x, 2 meters, 3 meters. And the internal force and internal moment is supposed to be like what? Here. Shear force is supposed to be going up or down? Timothy?
Shear force going up and moment going clockwise.
Right. So this is our free body diagram. And as usual, we can solve for the phi using sigma Fy equal to 0. Okay. The equation is still the same. because we still use x, right? And the equation there is W is equal to minus 200x plus 600. Okay, using sigma Fy equal to 0, what we will get here? Timothy, what we will get here?
V.
Yeah, V.
V minus the area of the triangle.
Okay, the area of the triangle. So W multiplied by the W multiplied by the 3 minus x, right?
Yes.
The W there is supposed to be minus 200x plus 600 multiplied by 3 minus x equal to 0. So your phi is supposed to be this one, minus 200x plus 600 multiplied by 3 minus x. Like that.
So should we divide it by 2 since it's a triangle?
Ah, yeah, forgot. It's supposed to be divided by 2. So that's the equation for phi. Okay, now using sigma moment of on the left edge, okay, this one, sigma moment at the left edge, what will we get there?
It's moment minus
or plus?
Plus.
Plus, right? Plus
Moment plus the
area, the area, right?
yes, the area of the triangle again.
So it's actually the same as the phi here, right? It's supposed to be minus 200x plus 600 multiplied by 3 minus x divided by 2 multiplied by the distance. What is the distance from the left edge?
3 minus x over 3.
Yeah, correct. 3 minus x over 3. Supposed to be equal to 0. Okay, so you get the minus, the moment. The moment there is supposed to be minus 200x plus 600, 3 minus x divided by 2 multiplied by 3 minus x divided by 3. Something like this. That is the moment, and this is the phi. Okay, how to draw the diagram in this case, Timothy? After we got the equation, all the equation.
How I did it is I plot the points at
actually,
0 and 2. Yeah.
Because it's quadratic, right? For the phi, we have a quadratic equation from x equal to 0 to 2 meters. From the moment, we have a power 3 equation. So in that case, right, what we do normally, right, this is our free. If this is the case, okay, if this is the case, then for the phi and for the moment, right, what you're supposed to do is try to find 3 points here. So for example, for phi, okay, using this equation, you can take 3 samples, x equal to 0, x equal to 1 meters, and x equal to 2 meters. You have to take samples, okay, you have to take samples at both ends of the first equation. So the first equation is for this one, right? This is the first equation, and this is the second equation. So what I do normally, right, for both V and M, for each equation, we have to take 3 data samples in order to create the graph. For example, okay, for the first equation, I will take the first data point here, the second in the middle, and the third is at the last. Okay, by doing so later, when you draw for the V and M, okay, you will get the 3 data point like that. So you can draw the graph. Okay, this one is just a rough estimation, not rough estimation. It's just rough drawing of me. Okay, the same for the second equation. For the second equation, this is the starting point and this is the end point. You have to take data points there and take one in the middle as well. So you have 3 data points. So later you can draw another curve like that using 3 data points. Okay, that's the way to do it. Okay, I will not exactly show you how to do it because it will be quite a while as well because the equation is quite long. Okay, so I will not draw it, but that's the way to do it. Okay, is it understood, Timothy?
Yes.
Alberto, is it understood?
There's one part that I want to ask.
Yes, you can ask it.
To find the moment, you multiply the W with 3 minus X divided by 3. Why is it divided by 3?
This one you mean?
Yeah.
Okay, so to find for the moment, right? Because it's moment is W multiplied by the area. So W multiplied by the length. Okay, so this one is triangle, right?
Yeah.
This one is triangle. So I multiply this with 3 minus X. 3 minus X is the length, and then divide it by 2. So it will be the area of the triangle here. So it's a force, right? Then the force, the centroid of the force is 1/3 from the left, right? Here, right? Because it's triangle, right?
Oh,
That's why.
yeah. Okay. Sorry, I forgot.
That's why the moment arm is 3 minus X, but divided by 3, right? Because it's 1/3. This one. Okay, you get it, Alberto?
Yes. Thank you, sir.
Okay. I think I will repeat the explanation in bahasa. Jika kalian lihat di sini, ini salah satu permasalahan yang cukup rumit ya. Kenapa kok rumit? Itu karena gaya terdistribusinya itu linear. Kalau gaya terdistribusinya linear, itu nantinya shear force distribusi shear force yang kalian dapatkan itu akan kuadratik, pangkat 2. Lalu momen dalamnya itu distribusinya akan pangkat 3. Seperti itu. Jadi agak sedikit kompleks di sana. Nah, bagaimana mencarinya? Yang pertama harus dilakukan itu adalah mencari terlebih dahulu persamaannya yang merepresentasikan si distributed force itu ya. Distributed force itu persamaannya linear. Kalian tahu kalau persamaan linear itu seperti ini kan? W sama dengan AX plus B. Nah, kita tinggal cari nilai A-nya berapa, nilai B-nya berapa, itu konstanta ya. Nah, yang kita ketahui saat X sama dengan 0, W itu 600, saat X sama dengan 3 meter, W itu sama dengan 0. Nah, dari situ kita bisa cari tahu, kita masukkan aja ke persamaan. X sama dengan 0, berarti ini 0 ya. A-nya juga ikut 0, jadi 0, bukan A-nya ikut 0. Ini jadi 0, 0 plus B sama dengan 600 Newton per meter, karena itu saat X sama dengan 0 ya. Ini ya. 0 plus B sama dengan 600. Nah, kita tahu B-nya 600. Lalu kita masukkan lagi untuk yang kedua, X sama dengan 3. Oke. Kalau kita masukkan X sama dengan 3 di sana, 3A ya, 3A plus 600 jadi. Karena B-nya udah tahu 600. Oke. Nilainya sama dengan berapa? Sama dengan 0. Karena kita tahu nilai W saat X sama dengan 3 sama dengan 0. Dari situ kita dapat A-nya adalah minus 200. Jadi persamaannya itu adalah W sama dengan minus 200X plus 600. Nah, Selanjutnya, kita cari reaksi di titik A dan B. Caranya bagaimana? Ya cari gaya terpusatnya yang merepresentasikan gaya terdistribusi itu 600 kali 3 meter bagi 2, 900 Newton. Oke, letaknya di sepertiga dari kiri. 1 meter ya, berarti. Ini jadi diagram area bebasnya. Kita bisa selesaikan, kita dapat bahwa AY 450, BY 450. Nah, itu masih bagian gampangnya. Sebagian besar dari kita bisa menyelesaikan ini. Sebagian besar dari kalian bisa menyelesaikan. Bagian susahnya itu setelah dipotong. Ini potongan pertama, ini potongan kedua. Oke, kita coba selesaikan dulu yang potongan pertama. Nah, kalau melihat potongan pertama, gambar diagram area bebasnya jadi seperti ini. Ada gaya terdistribusi, persamaannya minus 200x plus 600. Terus jarak kepotongan itu x, ini ya. Lalu ada gaya geser dan momen seperti ditunjukkan di sini. Ini positif ya, arah positifnya seperti itu. Oke. Nah, simple. Pakai sigma FY untuk dapat V. Dari situ kita dapat 450 minus V minus gaya terpusat akibat gaya terdistribusi sama dengan 0. Nah, gaya terpusat akibat gaya terdistribusinya berapa? Nah, itu yang agak rumit. Ujung kiri 600, ujung kanannya minus 200x plus 600. Oke, nah saya pakai cara rata-rata. 600 ditambahkan minus 200x plus 600 bagi 2, dikalikan dengan x. Itu jadi gaya terpusatnya secara total. Ini ya. Totalnya kalau sudah dikalikan semua, gaya terpusatnya jadi 600x minus 100x kuadrat. Dapatlah kita persamaan V-nya. Nah, kemudian cara cari momennya bagaimana? Kita pakai sigma momen di diagram area bebas yang ini. Sigma momen di ujung kanan biar gampang. Biar V-nya nggak perlu dihitung lagi. Oke, sigma momen di ujung kanan. Oke, itu apa saja yang ada di sana? Itu ada momen positif, counterclockwise, jadi counterclockwise positif. Lalu ada 450 Newton kali X clockwise, negatif berarti ya. Ini, gara-gara AY tadi. Lalu gara-gara gaya terpusat itu clockwise juga. Ada 2 ya, yang triangle dan juga yang rectangle. Saya sudah hitung dua-duanya di sini ya. Kalau yang rectangle itu besarnya minus 200x plus 600 dikali x, letaknya di tengah-tengah, jadi lengan momennya itu adalah x per 2. Oke. Ini. Nah, kalau yang triangle itu besarnya di sini minus 100x kuadrat ya. Kalau sudah dijumlah-jumlah jadi 100x kuadrat. Oke, lengan momennya 2/3x. Oke, dari kanan ya, karena kita ngitungnya dari kanan ya. 2/3x. Jadi persamaannya seperti ini. Dijumlah-jumlah jadi seperti ini. Oke, hal yang sama kita bisa kerjakan untuk diagram area bebas potongan yang kanan. Biar simple, saya mengambilnya yang ini. Yang sisi kanannya, bukan sisi kirinya. Nah, di situ jaraknya bukan lagi x lagi, ya, tetapi 3 min x, karena kita ambil dari kanan. Oke, ada gaya geser arah atas, ada momen clockwise. Ingat ya, ini sesuai dengan potongannya. Kalau potongannya ada di kiri seperti ini, gaya geser ke arah atas, clockwise. Momennya clockwise supaya tersenyum, seperti itu. Kita hitung lagi seperti tadi, dapat persamaan gaya geser, dapat persamaan momen. Nah, setelah kita dapat semua persamaannya untuk persamaan pertama itu X dari 0 sampai 2 meter, persamaan kedua dari X sama dengan 2 meter sampai 3 meter, kita bisa buat diagramnya. Nah, cara membuat diagramnya bagaimana? Di tiap persamaan, paling tidak kalian ambil 3 sampel. Ujung kiri, batas awalnya, batas akhirnya, ujung kanan, dan juga tengah-tengah. Untuk persamaan pertama dan juga persamaan kedua. Nanti kalian bisa buat grafiknya, baik V maupun M. Seperti itu. Oke. Jadi begitu ya, untuk kasus yang ini. Sampai di sini apakah ada pertanyaan? Is there any question for this particular problem? Okay, if there is no question, then I will discuss about this. Here. About the number 3. Okay, number 4, I believe is supposed to be simple enough, so it's for number 3. For number 3 here, wait a minute, Alberto. Okay, Alberto. Just now seems like there is none of you having a problem with number 3. What do you think, Alberto? How can you solve for number 3 here? The one in question is beam ABC. Okay, line diagrams for ABC. Yeah.
I first split the beam, so I focus on I focus on ABC first.
Yeah, you focus on ABC. Okay, but what did you do for the BE section?
BE.
Yeah. Because if you just focus on ABC, right? There's this one, right?
Yeah.
So what did you do with that? And what did you do with this one as well?
I just made the beam BE as like a moment.
So you cut it or what? I think I will not start with BE, but I will start with AD. Okay, because in order to draw for the diagram of ABC here, you have to know the reaction at A, right? Okay. What do you think about member AD here, Alberto?
Okay, wait. I'm actually starting to get confused. Wait.
Okay, so the problem is like this. It's actually is not that difficult, but you can see, right, the one in question is the diagram of ABC. But in order to solve for ABC, you have to know the reaction here, which is happening at A due to member AT, and then you have to know what is happening at B due to EB as well, right, Alberto?
Yes,
And
sir.
you have to know what is happening here due to C as well. Okay, so if we take a look at the whole frame, this one is actually a frame. Okay, can you find the two force member here? Whenever you find a frame problem, although it has a distributed force, you have to start with finding the two force member. Do you think that we have a two force member here?
I think I made BE as a two force member.
Huh? Sorry?
BE.
BE is not two force member because it's a fixed here, right?
Oh. Right.
AD is two force member.
Oh yeah, yeah, AD.
AD is two force member. That's why when we try to find out the reaction at A and at C, it will be quite simpler how to do it. So what we have to draw is just like this. This will be the free body diagram later. Okay, and at A there will be FAD like this. Okay, this one is FY FAD. Okay, and at C there will be CY CX. And here we have 80 kilonewton downwards. And we have distributed force here. 20 kilonewton per meter. Okay, Alberto, correct, right?
Yeah. Yes,
So
sir.
how many unknowns that we have here?
We have CY, CX,
FAD.
FAD.
So we have three unknowns. We have three equations. Sigma fx equal to 0, sigma fy equal to 0, and sigma moment equal to 0. Can we solve for those three?
Yes.
Yeah, we can solve for those three. So we can solve for CX, we can solve for CY, we can solve for FAD. Okay, but remember, whenever you find out a frame problem, although the one in question is the moment diagrams or shear force diagram, but the first thing that you're supposed to do is still to determine whether there is there any two force member or not. Okay, when you find out that there is a two force member, then yes, treat it as a two force member. So you just replace the member with the force representing to the two force member. Because for two force member, the force is always from one end to the other end, right? Like that. Okay. You get it, Alberto?
Yes, sir.
Now, in order to find out for the distribution at ABC, okay, distribution at ABC, right? If we have this kind of condition, right? Sometimes you have to take a look at that condition. There are two treatments that you can do there. Okay, I'm not so sure whether you do the first one or the second one. So if we want to draw for the shear force and moment diagrams here, how many cut that we have to do, Alberto?
Where? If we want to find one?
Yeah, if you want to find the shear force and the moment diagrams, how many cuts that we have to do? And where the cut that we're supposed to give? How many sections?
I think supposed to be just one cut.
One cut. Are you sure? We need A, B, C, right? This one.
Oh,
This
so,
one we have
so
distributed
two
force.
cuts.
Yes, this one is distributed force, and this one is nothing here, right? So we have to do two cuts, right? Do you still remember how to determine whether we need how many cuts, Alberto?
If there's one with no force and force.
Yeah, if there is no force there, it means it must be a continuous. So one cut can represent that part. And if there is a distributed force and there is no force beside the distributed force, it will be continuous as well. But here, A here, there will be force, and there is a distributed force here, right? So from AB to BC, the distribution will be different, right, Alberto? So we have to represent it with different cut here. You get it?
Yes.
So we cannot represent it with one cut. And beside that, at B here, there is a member, there is a BE there, which is connected there. So we have to represent it with different cut. Okay. So the first cut is this. It will be quite simple, this one, first cut here. So if we draw the free body diagram, it will be just like this. And there is a force FAD there. Assume that we already got the FAD, right? Okay. Shear force positive is supposed to be going up or down, Alberto?
Shear force positive up.
Up, are you sure? It's
Sorry, down and the moment go up.
okay, like this, right?
Yeah.
So you can solve this, and for the first section is supposed to be solved, and then how about the second section?
Second section.
This one. Which part that you're supposed to take then in this case? You want to finish this, the left cut or the right cut?
Maybe just the right cut.
The right cut, because it will be simpler. Okay,
Yeah.
right? The right cut will be simpler. If you draw the right cut, it will be like this. Okay, there will be cy, cx, assume that you know the value already, and there will be distributed force. 20 kilonewton per meter. Okay, here the shear force is supposed to be going up or down?
On the left one,
Yeah, on the left.
shear force
Positive.
going up.
Yeah, correct. Shear force going up. Moment. Moment is always up, right?
Yeah, always up.
And for this one, the distance here is x, right? For this one, the distance is what?
Top is x, so that one is
0 is always from the left here. So this one is x. So this one is supposed to be what? If that one is x, this one is x as well.
8 minus x.
Right, 8 minus x, 8 minus x. So from this one, we can find phi and m, right, Alberto?
Yes.
But sometimes you are, it is impossible for you to take from the other sides, right? If it's impossible for you to take from the other sides, right? For the second cut, like it or not, we have to take the left cut, and it will be slightly more difficult if we have to do so, because if we have to do so, right, the free body diagram later will be like this. And the force there, it will be FAD there, FAD, and there will be 80 kilonewton here. There will be distributed force here. And there will be the phi supposed to be going down and moment going up. Okay, if we have to solve for the left cut, for the second one, if we have to solve for the left cut, the free body diagram will be like this. Correct, right, Alberto?
Yes, sir.
Yeah, you can solve it that way. Or sometimes it will be simpler if we move the force here. But because we're moving it like that, there will be a moment as well. Okay, there will be a moment as well. So it's actually up to you. You can solve it this way, okay, or you can solve it like this. Distribute force. But here, beforehand, we solve for this. Done. So there will be a normal force. And there will be moment as well. Clockwise, counterclockwise. Counterclockwise, clockwise, yeah. Okay, using sigma Fy equal to 0, we will get that N normal force is supposed to be equal to 80 kilonewton, and moment is supposed to be equal to 80 multiplied by 4, so 240 kilonewton meter. Okay, then you can move it here. Sometimes we can do, we have to do it that way. And remember action and reaction. We have 80 kilonewton here, and moment, this one is clockwise, so this one is supposed to be counterclockwise, 240 kilonewton meter.
Sorry, where did you get 240?
Wait a minute, moment. 240 is from this, the calculation of the moment here. because actually I can cut it here, right?
Isn't it supposed to be 80 times 4?
Yeah, 80 times 4. So through 80 times 4 is 320, right? Okay, sorry. I made a wrong calculation. 320 kilonewton meters. So actually you can do it that way. Either you can do it this way, just do the calculation that way, or solve for the cut first and then move the moment and force to the cut, to the particle cut, to the edge like that, and solve for the simplified free body diagram like this. Okay, Alberto?
Okay, sir.
Because sometimes we have to do it this way. I think I can show you to you guys where in which condition that we have to do it that way. Yeah, this one. This is one example. Okay, you can see, right? Actually, it is simpler than our number 4, our number 3. But in this case, the one in question is the distributed force here. The moment, sorry, not distributed force, but the normal force diagram, shear force diagram, and moment diagrams at this particular beam. Okay. In that case, what the first thing that you're supposed to do is to solve for reaction at A and B. Okay, using the whole free body diagram. A there is supposed to be here, y, ax. At B it's supposed to be by, and there is supposed to be f here. Okay, f is 10 kilonewton. Using sigma fx, sigma fy, and sigma moment, we can get ax, ay, and by. Okay, we will be able to solve that. Okay, then in order to draw the free body diagram, in order to draw for the shear force diagram, right? In order to draw for the normal, shear, and moment diagrams, then sometimes we can just move this to this particular point. But in this case, mostly we don't have to do so. But in some other case, we have to do so. Okay. So when we draw for the shear force diagram and moment diagram, we need two cuts. This is the first cut and this is the second cut. Okay. But sometimes as well, you are asked to find out the distributed normal shear and moment diagram, which is happening at this location. Okay, in that case, then our cut, we need several cuts here, 1, 2, and 3 here. We can still draw it that way. Okay, so this is the first cut, this is the second cut, and this is the third cut. Okay, if we solve for the first cut, it's supposed to be like this: the free body diagram, ay, ax, phi, m. We can solve for this. This one is x. Okay. How about the second cut? The second cut is simple as well. Slightly longer. Ay, ax, by, phi, m. And this one is x. Okay, we can still solve it. Okay. How about the third cut? The third cut, it's better for you to just take that one. So we can just do it this way. 10 kilonewton. Now, what is the positive direction that we're supposed to give here? Because now the cut is over here. Previously, the cut is horizontal, and now the cut is vertical. Okay, one of the assumptions that you can take is you can make it consistent. So going up is like this, and in this case is like this. That one. So in this case, our phi is supposed to be like this, and our moment is supposed to be like this. Because sometimes this one is there is a question like this, okay, where you have to find the distribution here as well. We have to find the diagram here as well. Okay, Reinhard, can you catch up with this one?
Yes, sir.
So not necessarily when we find out for the distribution is just one horizontal piece like that. Sometimes it can consist of a horizontal and vertical as well. But you don't have to worry about it as long as you make it consistent. Okay, going up like this here, going up like this, and in this case, going up is like that. Okay. Any question in this particular problem? There are several things that I give it to you guys today, right? When we handle this kind of problem, okay, sometimes we can move the force to the beam where we handle it. But remember, when we move the force, sometimes it's not just left with the force only, but sometimes it will create moment as well, like this one. That's why here, when we move it, there will be 80 kilonewton downwards and 320 kilonewton meters there. Okay. Any question about this? All the topics that I covered today? Any question? And don't forget, okay, the exam will be this Saturday. The date. Sorry. This Saturday is 6, right? Sorry, 9 April. Saturday, 9 April, 12:30 p.m. You better stand by in the class, okay? Because the exam will start at 1 p.m. Ya, jadi hari Sabtu hari Sabtu 9 April jam 12:30 siang kalian sebaiknya sudah standby di ruang ujian, oke? Karena ujiannya akan dimulai dari jam 1 siang. Nah, ujiannya itu kemungkinan besar akan offline. Okay, so the exam will be not most possibly, but it will be offline. The exam will be offline. Okay, and most likely there will be no online option here, unless you are sick. Okay, unless you are sick. So there will be no online option unless you are sick. So it's better for you to come to Bandung as soon as possible, because the exam will be offline. Okay, and one thing that you have to prepare, one thing that you have, the things that you have to prepare for the exam. Bring your pen. You have to bring your own pen. Okay, you have to bring your own ruler. Okay, and you have to bring your own calculator. Okay, and beside that, you have to bring your student ID card, student card. and Indonesian ID. Okay, so KTP. This is the things that you have to bring in the offline exam. Yeah, for the answer sheet, we will provide it for you. Oke, jadi untuk ujian offline ya, kalian harus mempersiapkan ballpoint, penggaris, kalkulator. Intinya alat tulis itu kalian harus siapkan semua. Kalkulator tidak diperbolehkan menggunakan HP ya. Okay, you are not allowed to use your cell phone to become your calculator. So you have to bring a dedicated calculator. Okay, beside that, selain itu ya, kalian juga selain harus membawa alat tulis, kalkulator, kalian harus bawa KTP dan juga kartu mahasiswa. Seperti itu. Untuk ujian ini, apakah dipahami? Silakan jika ada pertanyaan terkait dengan ujian. Costanzo Vero, apakah ada pertanyaan? Halo, Costanzo.
Permisi, Pak. Katanya lagi di toilet, Pak.
Oh, oke. Rasel Herlambang, kamu ada pertanyaan untuk ujian offline?
Tidak, Pak.
Oke. Kita coba diskusikan yang lainnya ya. Sebentar, stop share. Oke, ini. So basically, I try to collect all the exam problem that we have given to you guys. Okay, we can review it together. You can see, right? This is the exam in 2015. Okay, it's been a while since the first time I teach in IDB. So I start teaching in IDB in 2014. Okay, you can see this is the problem in 2015. For this particular exam, we only have 2 problems. But I'm not so sure about the exam on this Saturday, whether it will be 2 or 3 problems. Okay, if it's 3 problems, most likely it will be frame problem, machine problem, and internal force problem. And if it's 2 problem, most likely it will be machine problem and a combination between frame and internal force. Okay, so it can be anything. Okay, it can be 2 problem, it can be 3 problem. As you can see here, this is example of combination of internal force and frame problem. Okay, and the one in question is CDE. You can see there, right? CDE. Okay, CDE. We have to find for the distribution. We have to find for the internal force diagram for the member CDE. You can see that it's not necessarily always a straight member that we are asking in the exam. Sometimes it can be combination between straight and vertical. In this case, there is a horizontal part CD until this particular point, and then from this particular point till E, it's a vertical. But we can still do that. Okay. I think I will review this with you first. Maybe after this, we will try to solve for this particular problem because it's quite interesting as as in this particular case, 300 Newton, in order to find the force at point E is quite complicated. Later we will discuss about it. Okay. This is another problem that we have given to the students before. This is a machine problem, and this one is combination between frame and internal force. Okay. For this one, you can see that there is a two force member there, and then there is a distributed force here. Okay, you can use this as your practice problem as well. Okay, what else? Then we have this as well. Okay, I believe this one I already give it to you for your homework. Okay, but for this one we haven't discussed it yet. This one we haven't discussed it yet, but I think it's quite the same as before. Okay, this one is an internal force as well. So we have to find the diagram. This one, GED is the one that is in question. This one, the horizontal one. Okay, if you find this kind of problem, combination between frame and internal force and moment, what you're supposed to do is, as usual, solve the frame problem first. Find out the two force member. In this case, we have two force member CG. Then solve for the then replace the CG there with two force member with a force in the direction of CG. Okay, and then we have two multi-force member ACD and GED, and beside that we have pulley as well. So for the pulley, you have to transfer the force to the joint where it is connected to. Okay, this one is quite interesting as well, so we can try to practice with this problem. What else? Let us take a look. Yeah. This one is the exam problem. I believe in the pandemic. It's last year. This one is last year problem. So it's quite complicated there. Okay, but it's still solvable. Okay. And this one is a machine problem. I believe I haven't given to you yet, but it can be solved as well. Okay. I think for you to practice, right? Later, I will not consider this as a homework, but later, all of this exam problem, which has related that I haven't given to you yet, I will put it in one slides. Okay, I will put it in one PPT, and I will post it in the EduNext so you can practice by yourself. Okay, before the exam on Saturday. Okay, but for today I will discuss one of the problem, and tomorrow please take a look. Try to take a look at the previous exam problem. If you have any problem solving that, tomorrow we can discuss it in the class. Okay, we can discuss it in the class tomorrow. You can ask question about internal force diagram, internal moment diagram, or you can ask as well about frame and machine. Some of this frame and machine I haven't given it to you yet. Okay. I think for today, I will try to concentrate on this particular problem. Wait a minute. Let's discuss it a bit before we wrap up the class, because this one is quite interesting. Okay, don't forget. Sorry. After this, I will post the file in the EduNext. You can check it, and if you have any problem with any of those, tomorrow we will discuss about it. Okay, because I will have there will be not enough time for me to discuss all the problems that have been there in the previous exam. I'm sorry, the problem is in Bahasa because at that time we don't have the international class. Okay, so let's discuss this together before we wrap up the class. Okay, this is the problem that we want to discuss just now, and as I told you, this one is actually a combination between frame and internal force and internal moment diagram. Okay. Jeffrey. Hello, Jeffrey. Hello, Jeffrey. Not there? Who was there? William Nathan. Hello, William Nathan. Hello, William. Why so many of you are not answering my question? Raditya Imanajati. Hello, Raditya.
Yes.
Okay, Raditya. What do you think about this, Raditya? Where are we supposed to start, Raditya? Where are we supposed to start, Raditya? Is there any two force member? Because it's a frame problem, right? Always start with that question. Is there any two force member here?
No.
No, no. There is no two force member. Yes. So all the members there is all the member there are multi-force member. So after we know that there is no two force member, what we supposed to do next?
Solve for reaction forces.
Sorry?
Solve for reaction forces.
Reaction forces, correct. So in this case, we have A and C, right? So we try to solve for reaction forces at A. So I will draw the free body diagram like this, because we just need to solve for the external forces, right? So I will not draw the detail. So I will just draw like this. Okay, there is a 300 Newton here, 300 Newton here. At A there, what do you have at A?
AX and AY.
X and AY. X. Hello. Oh, I see.
CX and CY.
I use CX, CY. This one, although it's not looks like it, but actually C is a roller there. If it's a roller, it's supposed to be what?
CY.
Only CX, right?
Yeah.
Yeah, only CX. So in this case, we have how many unknowns?
3.
3 unknowns, and we have 3 unknowns, and we have 3 equations: sigma fx equal to 0, sigma fy equal to 0, and sigma moment equal to 0. Can we solve this today?
Yes.
Yeah. Okay, so we can solve this 3. Okay, after we solve that, then we have to take a look. The one in question is the internal force and internal moment diagram of member CDE, right? Okay, if you can see there, in the member CDE, okay, in the member CDE, there are 4 reaction at C, we know it already. Then there is a pin D there, and there is a pin E there, right? Aditya? Correct,
Yes.
right? Yeah. So in order to solve for the internal moment and internal force diagram, like it or not, we have to solve for those 3 joints, right, Aditya?
Yes.
We have to know the forces which is happening at D and at E as well, because we only know about the up until now we just found out about the forces which is happening at C, right? So we have to find out this and this. That's our aim in the frame. Okay, in the frame problem, that's our main aim. Okay, so basically, guys, if you find a problem where it is combination between frame problem and internal force and internal moment diagram, okay, try to take a look after you solve for the external forces. Try to take a look which member that you have to draw for the moment, internal moment and internal force diagram. Take a look at that particular member, which join there that we haven't got the value, the reaction forces yet. Then we concentrate on that. So in this case, okay, later, if we draw the free body diagram of a member CDE, this is what we got, right? There will be CX that we know from the beginning. At D here, it's supposed to be what? Raditya.
FDB. No, sorry. DX and DY.
Correct. Dx and dy. How about at E?
EX
Same,
and
right?
DY.
Yeah. Y, X. So that's one thing that we supposed to find out first. So the x dy, ex ey, we have to find it out first. Okay, how to find out for those 4 unknowns? The first unknown cx, we already find it out from the external force from the whole free body diagram. Okay, now we have to find out for dx dy, ex ey. Okay, in order to solve for dx dy, okay, ex ey, it will be here. Dx dy, it will be here. So we have to draw for all the free body diagram here. So now I will take a look at ABD. Okay, ABD there will be dx dy by the opposites of our dy dx there. Then there will be bx by. And there will be axay. Okay, axay here, we already solved it from our main free body diagram, the whole free body diagram. So now we left with 4 unknowns there. We still cannot solve it, right? Okay. Now we take a look at the BE, member BE. For member BE, there, PX, PY, it's supposed to be like this, PY, PX, then A, this one is supposed to be E, sorry. Then this one is PX, PY, sorry. And then there is a 300 Newton. 300 Newton. Okay, so we have 3 free body diagram that we haven't solved yet. And in total, how many unknowns that we have? Hello, Aditya? In total, how many unknowns that we have? Hello, hello, Aditya? Where is Aditya?
8.
8, are you sure? What is 8? dx, dy. This is 1, 2. ex, ey. 3, 4. Okay. And then px, py, right? Only 6, actually. Okay, we only have 6 because EXEY here is a repetition of the first EXEY, and PXPY here is repetition of the first PXPY. DXDY here is a repetition of the first DXDY. So in total, we only have 6 unknowns: DXDY, EXEY, and PXPY. Correct, right?
Yes.
And how many unknowns? How many equations that we have here? We have 9. Okay, sigma fx, sigma fy, and sigma moment here for this particular free body diagram. Sigma fx, sigma fy, sigma moment for this particular free body diagram, and sigma fx, sigma fy, and sigma moment equal to 0 for this particular free body diagram. So we can solve it. Although to solve it, you have to use substitution and elimination. Okay, Raditya?
Yes.
The main question there is where we supposed to put the 300 Newton, this one. Should we put it at member BE, or should we put it at member CDE at E, or we supposed to put it 50% at member BE and 50% at member CDE? Anyone can help me with this question? Anyone can help me with the solution of this? Muhammad Hilmi, menurut kamu bagaimana Muhammad Hilmi?
Wing
300 Newtonnya harusnya diletakkan di mana? Gimana?
Wing
Bingung. Okay. Fauzan Ahmad, what do you think about this, Fauzan?
I think it's okay to divide it equally or just put it in one member.
Actually, that's the answer. You can put it anywhere. Actually, you can put 300 Newtons here. You can put 300 Newton here at point E at member CDE, or you can just divide it into 2, 150 at member CDE and 150 at member BE. It will be the same. But later, the value of EY, the value of your EY will be slightly different. Okay, but at the end, the total force, vertical force, the total vertical force which is happening at the pin E there for member CDE will be exactly the same, whatever you choose. You can choose it like this, or you can choose it like this. This one is 150 Newton, and there is another 150 here. You can choose it this way as well. But the only difference is the value of EY later. Okay, for me personally, I will choose this one. So all the forces happening at pin E, but at member PE. So there is no force here. But later, that 300 Newton will be there in our EY. So that's the difference there. The EY value will be different for every case that we choose 300 Newton all at PE, or 300 Newtons all at CDE, or 150 at PE, 150 at CDE, like that. The EY value will be different, but in total, the force which is happening at pin E at both member CDE and member PE will be the same. Will be the same. Okay. Apakah dipahami tadi? Tadi siapa? Hilmi, apakah dipahami tadi? Jadi bisa di manapun, ya. The main problem here is to find out for EX, EY, DX, DY. Okay, because you have to combine equation from 3 different free body diagram. In total, you have 9 equation. In total, you have 9 equation. Okay, in total you have 9 equation, but you only need to solve for 6 unknowns, so you can use that. You can solve it. Okay. So basically, that's the way to do it. And as usual, after you solve for CX, DX, DY, EX, EY, okay. So you have it like this later. Okay. CX, DX, DY, DX, DY, yeah. EXEY. Okay, after you solve for this, Zafia, pertanyaannya adalah berapa potongan yang kita butuhkan untuk membuat diagram gaya dalam dan juga momen dalam, Zafia?
2, Pak.
2. Ayo, yakin 2. Ada yang vertikal ya?
Oh, 3.
3. Ini 1, 2, 3. Okay. If we take a look at the first cut, it's supposed to be like this. CX. Remember, because there is a horizontal force, so I will put the normal force here. Shear force, V, and moment. This is the first cut. Okay. For the second cut, will be slightly longer. CX, DY, DX. Because there is a horizontal force, yeah, I will put normal force, V, and moment. Remember, going up is like this, right here. But in this case, going up is like this for the horizontal, for the vertical part. And the last cut, in order to make it simpler, I will cut the right side, the top part. So this one is our cut UI, X, okay. And because it's like that, there will be normal force. This one is normal force. This one is shear force. This one is moment. Okay, remember the normal force and shear force here and here is interchanging. Okay, the normal force is always at the same direction as the beam. The shear force is always perpendicular to the beam, like that. Okay, You can solve this, you can solve this, you can solve this, and you can draw for the internal diagram. When you draw for the internal diagram later, it's okay for you to just make it a full horizontal to represent for this one as well. So this one will be the first equation, this one will be the second equation, and this one will be the third equation. First, second, third, like that. Okay, this one is our x, this one is our x, and this one is our x. Okay, because x is always from the left edge, like that. So for the vertical cut, the x will be longer as well. It will be like this and like this. This is our x. Okay. I think because his time is up, right? I will post some of the previous exam problem in the EduNext. Try to take a look at it. Try to solve it. If you have any problem solving it today, tonight, right? Discuss it with me tomorrow, because tomorrow is your last chance to discuss it with me about for the exam. Okay. I think that's all. Thank you very much for listening. See you guys tomorrow morning. Okay. Bye.
Thank you, sir.
Yeah. Thank you. Thank you.
Thank you, sir.
Thank you, sir.